Okay, today we're going to start 6-1, law of cosines and sines. Today and tomorrow we're law of sines, then we do law of cosines on Monday, and then we do area. And when we do area, we put everything together. Your instructions will be to solve the triangle and find the area. So to solve a triangle, you have to find every piece of it. And then you find the area. So I'm telling you on your test, I think it's 6 or 8 problems, one of the two. And your instructions are solve the triangle and find the area. That's it. And so we will build on that. It's important that you do today's homework. So tomorrow when I throw at you that there can be 2, you know how to do 1. This is a process that goes pretty quick. And if you haven't practiced it, I promise you tomorrow you will be completely lost. We don't have time to add extra time, and I'm not adding extra time to these concepts.
The assignment should not take 5 hours.
No. Okay, the Pythagorean theorem, what is it?
A squared plus B squared equals C squared.
So A squared plus B squared equals C squared. And it can only be used on what kind of a triangle?
Right.
A right triangle. So if I gave you a triangle and said solve it and it's right, that's what you would use, correct?
Yes.
But what happens if it's not right?
Then you use the law of sines.
You use the law of sines or cosines. Before now, you would have had to bisect this angle, make 2 right triangles, solve each right triangle, add the you'd have to do a lot of work, right?
Yes.
So what the law of sines says, first of all, it can be used to solve a triangle where we know, we're given 2 angles and a side, so that would be angle, angle, side, side, angle, side. Or we're given 2 sides of a non-included angle, which would be side, side, angle.
What about angle, side?
There is not an angle, side, side, only the person who tries to use it.
I remember this stuff.
So, this is just a way of classifying it, and I'm going to tell you, I don't typically say it's an angle, side. We can use law of sines. I talk about the pieces that we have. Okay, so this is a non-right triangle. I would encourage you to make your triangles non-right when you are drawing them. If you make them right in your brain, you're going to try to use the Pythagorean theorem. Okay, so these are non-right triangles, every single one of them. So how it works is the sine of A equals divided by the side of A is proportional to the sine of B over side B, which is also proportional to the sine of C over side C. Now, we know that to solve proportions, we don't need 3, do we? No. So I could cover up this as long as I have 3 parts of these. There's 4 pieces of information here, correct? Angle B, angle C, side B, and side C. As long as I had 3 of those 4, could I find the other one? Yes. If I covered up this, the same thing. Covered up this, the same thing. Now, I will tell you there is books. I think our book does it also. They write it also like A over sine of A equals B over sine of C. B, how would I keep it right? And C over sine of C. Now, they make you think these are 2 different things. Are they 2 different things? No. I've just reciprocated them, correct? I would encourage you to keep what you're solving for always in the numerator, but you don't have to. As long as you do the algebra right, you can solve it anywhere. You know how to, those skills you have. Just make sure you do it correctly. So what this means is if I have an angle and its side, as long as I have one complete set, I can use this. So an angle and its side gives me that complete set. You'll hear me say, does it have a complete set? Well, does it? Yes. Then we're going to use law of sines. Law of cosines is just a more complex process. Law of sines is much easier. So if you can use law of sines, you always want to use law of sines because it's just easier to do, quicker, more efficient. But I will tell you, if you start with law of cosines, you have to finish the problem with law of cosines. You can't jump ship to law of sines. Okay. The same thing if you start with law of sines, don't jump ship to cosines, but you won't want to, but I just got to make that clear. If you do, there's adding an extra step to verify that you've picked the correct triangle. You may have to find 2 triangles and decide which one's a good one. And I wouldn't want to add that extra step in myself. So as long as I have one complete set and one other piece of information, I can use this. It doesn't have to just be A, it doesn't have to just be B, just... Excuse me. Now, other question for you. If I'm giving you 2 angles, is the third angle a given?
Yeah,
Yeah, why?
because
You add them together and then subtract it from
Okay, so they only can add up to 180 degrees, correct?
Yeah.
So if you are given from the beginning 2 angles, the third one is a given, so you can use that to solve your triangle. I will tell you right now, your rule is, and you might want to write this big bold letters everywhere, you use what you were given, not what you find. Use what you are given, not what you find. Now, of course, if you have to use what you find, then you use it, correct?
Yeah.
But what's wrong with using what I find to find other pieces of a
You're not
triangle?
always right.
Yeah, if I mess up, am I going to mess up everything then?
Uh-huh.
Yeah. There will be times that you have to use something you found, but in general, use what you're given. Okay? So, I could give you tons of examples, but you get what I mean by a complete set here. Okay. So that's, in this case, so the first thing you're always going to do is draw a triangle. My triangles tend to always look the same, but just make it not look like a right triangle.
Mine looks like a Dorito.
A Dorito?
Yes.
Okay. As long as your sides are straight.
Triangle.
That's where it's bread and so. Nope.
Okay, so the only thing I put on my triangle is what I'm given. That way, I don't try to use what I find. Does that make sense?
Yes.
Okay, so I know angle C is 107. Totally didn't draw my picture correctly, but it doesn't matter because we always follow the numbers and not the picture, right? And then side B always goes across from angle B. That is an important thing, that if you aren't drawing your triangles correctly or labeling your triangles correctly, are you going to get the right answers?
No.
No. Okay, do I have a complete set?
Yeah.
Yes.
Side B.
I have angle B, side B, right? Okay, we're going to have to find, when I say solve a triangle, it means find all the angles and all the sides. So I have 3, so I only have to find 3 more things, and then when we get to area, you'll have to find area. Make sense?
A.
So angle A would be easy.
48 degrees.
So angle A equals 180 minus 25 plus 107. And you guys said 48 degrees?
Yes.
Okay, I have to see your work. You cannot just tell me 48 degrees. Because sometimes when I add 25 and 107, I get 123. Or 133, excuse me. What'd I do wrong? 5 plus 7 is not 13, is it? It's 12.
Oh,
So if you show me your work, can I see that you're doing it correctly?
Yeah.
Yes. I will let you use some calculators on here, but it's when it's appropriate. If on your test you use your calculator on every single problem, you won't finish your test, and I won't give you extra time. Your calculator is used when it is appropriate, and we will talk about that more. Okay, so we found angle A. Now what would you like to find?
Let's do B, capital B divided by
No, what side? Do you want side C or side A?
C.
C. You guys okay with C?
Yep.
Okay, so I'm going to use this one here, just because I always like to keep my X, my unknown, in the numerator, but does it matter?
No.
No. We'll do the other one this way. How about that? We'll do one the other. Okay, so C over sine of C. Well, what is angle C?
107.
107 equals, and then I use my complete set. So if I put a side on the top, I have to have a what on the top? A side. Over sine of 25.
Oh, this is
So then I would multiply over by sine of 107. Do you see all my work here? Yes. I should see all your work. So this equals C. So is this appropriate time to use calculator?
Yeah.
Yes. All at one time. So I have 15 sine of 107.
How did you change it from, wait, do you need to be in degrees or radians?
Which one do we need to be in? Degrees. How do you know?
There's degrees in the problem.
Because there's degrees in the problem. How do I change that? Mode.
How did you change it?
And then I go down. I'm going to leave mine. You guys change yours. I'm going to leave mine because I'm going to show you. Okay, so I have 15 sine of 107 divided by sine of 25. I don't need parentheses in the numerator over the whole thing because it will follow order of operations where it says left to right, multiplication, division. If you want to put them there because you forget to put them in the denominator, then do it. It doesn't matter. Now, this is what I got. And I know you didn't get that. Why should I know that I'm wrong, first of all? No.
You have a negative.
I have a negative side length. Can I ever have a negative side length? No. We're not in the coordinate plane, are we?
No.
We are a random triangle out there in the universe. It is never going to have a negative side length. Now, in the coordinate plane, I could do that, but I'm not there.
What did you do wrong?
I didn't switch it. The first thing I would always do is make sure. So did you get 33.94?
Yeah.
Okay. Always go to the nearest tenth unless they give you more.
So 33.9.
Yep. And it's approximately 33.9. And do we have a unit? No. If I had a unit, would I put it there?
Yes.
Yes. Always go to the nearest tenth, again, unless they give you, if they give you the hundredth, then you give them the what? 100. Okay.
So now let's do B.
Now let's do B, and we're going to do B with the angle on top. So, not B, you mean A?
A.
So we have sine of, and A was 48, correct? Sine of 48 over A equals sine of 25 over 15. Again, using that complete set I was given, not using, why would I not want to use this C and angle C?
Because
you round.
I round it, correct? And if I round it and then I round it again, I'm making my rounding error worse and blah, blah, blah. Okay, so in this case, I would have to multiply over by the A, correct? But then multiply by the reciprocal of this.
Yeah.
So I would get A equals 15 sine of 48 over sine of 25. So it wasn't much harder, but did I have to do an extra step?
Yeah.
Yep. So I just always try to keep what I'm looking for in the numerator. It just makes it easier. But as long as you reciprocate everything, can you do it? Okay. So what do you get?
26.4, approximately.
Yep, that's what I got. So I have approximately 26.4. I want to put degrees on that. Anyone else?
Why'd you switch it instead of doing A over sine of 48?
I just showed you could.
Okay.
So now can we put them in the triangle?
No, just leave it.
No? Okay.
You have labeled your work, correct?
Yes.
When I go to check this problem, I can see angle A. I see an A. I will tell you on the test, it looks like this. And underneath of it, I would have A, C, angle A, and then area. I'd have it just like written A, C, angle A, and then area. and you will do all your work underneath and put your answers up here. You notice I didn't put an equal here, did I?
No.
Because it doesn't go in equal here, does it?
Approximately.
It goes in approximately. But what about on angle A? Does it go approximately or equal to? Equal to. So I don't put that in there. You have to make that decision. The other thing there is going to be is there always is going to be an A prime, a C prime, an angle A prime, and an area prime.
What's the prime?
There is a possibility of two triangles when you use law of sines, and we will talk about that case when that happens. And we're going to talk about it tomorrow, but not today. But on your test, I will have room for two triangles on every triangle. Does every triangle have two triangles in it? No. I've already just basically said that. But you have to know when to look for one and when not to look for one. Okay? So it's going to be a very basic format. Your test is going to have a lot of blank area because you need all that area to work. So let's do another one. What's the first thing I do on number 2? Draw your triangle.
There's no complete set, by the way.
There is not. And you will notice I draw my triangles different every single time because I try not to get stuck in a rut. And your triangle does not have to look like my triangle. The only reason we are doing these is so we have a reference. Okay, so 2 people so far have said we have no complete set, but we do. It's not there, but we do, don't we? Because angle A is angle A a given? Why?
Because you have two.
I have B and C, so angle A can only be one thing, correct?
It's 35.
Okay, so angle A is 180 minus 115 plus 30. And if you want to just put 115 minus 145, I'm okay with that. You still just need to show me your work. Make sense what I'm saying?
Yeah.
Okay, so it is 35 degrees. So now, do I have enough information? Yes. And the only reason it was given is because I was finding one angle. If I had to find 2 angles, it's not a given. Okay. So then I have to find side B and side C. I tend to do things in alphabetical order, just because. But sometimes you can't. So is side B okay?
Yeah.
Okay, so B. So it would be B over sine of B, which is
30 degrees.
30 degrees. Equals, well, our complete set is our A, right? So 30 over sine of 35. Now, it is important, guys, that you double check this, since we are using it as a given, that you double check it and make sure you're right. Okay, just make sure your subtraction. Sometimes we borrow and then don't borrow, and our answer would be 45 and not 35, things like that. Okay, so we do know the sine of 30,
1/2.
which is 1/2, correct?
So
So I have to multiply both sides by a half.
Would you multiply it by the reciprocal, so would it be multiplied by 2?
Well, I would multiply by 2 to get it in the numerator, but to move it to the other side, I would multiply by itself.
Okay.
Because you reciprocate, you know what I mean? You reciprocate twice.
80.
So half of 30 is what?
half 30 is
15.
15. I have not touched my calculator yet, have I?
No.
No. Now, do I know the sine of 35?
No.
No. So now I'm going to put 15 divided by the sine of 35 in my calculator.
Well, 26.2.
So approximately 26.2.
Centimeters.
And this one has a unit, so you need to use it.
Did we not need to take half of that?
No, we already did. We took half of 30. Half of 30 was 15.
Yeah, but do we not need to do it for both?
No.
That's not
It's not how multiplication of fractions works. Okay, find C.
Okay.
I hole punched your sheets, didn't I? Yeah.
Yup.
I got approximately 47.4. How about you guys?
Yep.
I didn't.
Okay, you notice I showed my work a little differently this time, didn't I?
You did it the second time.
Yeah, my brain was, I wasn't going to do it. And I'm like, I'm going to go ahead and do it. Because I never do this. Because I can move it around in my head. If you can move it around in your head, is that okay to do?
Yeah.
Yeah. If you put your unknown in the denominator, don't forget the extra step. But if you always put it in the numerator, it's pretty easily to just multiply over by the denominator, isn't it?
Can you
Yeah.
go over the C? Because I kind of got it the first time, but can you explain it again?
So it would be C over the sine of C, which is 115. And your complete set is your A. So side, sine of 35. Multiply over by the 115, and you get that. Is that what you needed?
I multiplied it by B. I got like the same thing. Am I not supposed to do that?
No.
Well, I got the exact same thing.
Well, if you'd be wrong.
It's the use when you are given, not when you find. Since A is
We gotta get that wrong.
Is that what you needed, Elena?
Yeah, that's basically what. I don't even know. I was looking, it looked to me like I don't even know.
Okay. The back is the ambiguous cases. We'll talk about it for a minute, but I'm not going to go over it today. If you look at the top, ambiguous means unclear. Ambiguous. It's unclear. What that means is there possibly could be two triangles. So if I were drawing a triangle and I said my angle is here, this is an obtuse angle, correct? There can only be one obtuse angle in a triangle.
Yeah.
Yes? And I draw it down and I hit once, I have one triangle. But if I drew it down and I don't hit at all, then I have what? No triangles. Sometimes we don't have a triangle. I'm not going to go over if this is bigger, if this is smaller. I just want you to look at the pictures. Because what happens until you do this a lot, if I try to explain all the use it if here and use it if here and use it if here, you forget what the ifs are and you don't look. So if I can use law signs and I'm only given one angle. So if I could use law signs but only given one angle. So what that means is if I gave you this A, B, C or E, F, G or whatever triangle it is, and I gave you that this is 36, and I give you this is 10, and give you this is 15, do I have enough information to use law signs?
Yeah.
Yes, I do have enough information to use law signs, but don't pick it up again. You, stay off your phone. You, stay off your phone. You just had your phone in your hand. You just.
You're still.
Okay, anyway,
Ethan, what are you listening to?
so you shouldn't have your headphone in at all.
Keep it out.
Okay, but so I can use law signs, but there's only one angle, correct? So tomorrow we will look for that second angle and decide. Sometimes it's no second angle. Sometimes it looks like this, but sometimes there's two triangles. See that's the triangle? See that triangle?
Yeah.
Okay. I cover up the diagonal. Do I still have another triangle?
Yeah.
Yeah. So sometimes you can have two triangles.
That's annoying.
Yep. Okay. I have 4 examples. I don't know if we need 4 examples. You guys want to try it on your own?
I can try.
Sure.
Okay.
Yes. Thank you for being nice.
Who?
Miss me.
For what?
Making us do our own.
That makes sense.
Sine of 120 you should know, so you shouldn't be using a calculator for it. I'm not going to tell you when you should know things. You should know you know them. Why should you know 120?
Because you just know.
How far is 120 from 180?
You just know.
60. So it's a 60.
Don't use your whole space on this one. Cut your... Actually, don't do that one.
I'll just send it.
No, you can, but don't do it.
You can throw the paper away if you want.
No, I think these are examples for tomorrow. That's why I messed up. Okay, they are. We're done for today. No, you can, you can do this problem. How can you, what's the first thing you have to find? Angle B. It is the only thing you can find, correct? So let's do it real quick because you're all telling me it's impossible. That kind of frustrates me. Okay, so the formula says sine of B, correct? Divided by B, which is 15, equals sine of 120 over 22. So then I would multiply over by 15, correct? So I have sine of B. Actually, I'm not going to write sine. Well, I will this time. I won't do it again because I will skip to the next step. So I have 15 times, what is the sine of 120? Yes. Square root of 3 over 2 over 22. Now, I have sine of B. I need B. How do I find an angle? Inverse. So this is equal to the inverse sine of 15 square root of 3 over 2 divided by 22. Or you could multiply by 1, 22, so 44. Doesn't matter how you put it in your calculator. Just put it in your calculator the right way.
The inverse of sine?
Yep.
Why is it the inverse?
Because you're looking for an angle.
Because inverse is fine.
Inverses find angles. Inverses switch range and domain.
You get 44.
I get 36.2.
Miss Mick, where'd you get 44?
Oh, where'd I get 44?
Yeah.
Okay, this is, I thought you said you got 44.
No.
This is 15 square root of 3 over 2, correct?
Yeah.
Divided by 22 or multiplied by 1 over 22. And 2 times 22 is
44.
44. So I get approximately 36.2. How about you guys?
Yeah.
Okay, so and at this point, we would have to check for a second triangle.
36.
This would be triangle 1, and this would be triangle 2. And we'll do that tomorrow. But I told you not to use the whole thing. No, I would highly suggest when you're looking for 2 triangles, you do half on this side. Because we'll do this step, solve the whole second triangle, and then come back. Okay, so all you're doing today is the one case. You don't have to check for 2 triangles. We're going to work on that tomorrow after you know how to do the formula backwards and forwards.